Alright guys, today we are going to be looking at lesson 7.2, which is experimental and theoretical probability. Our learning target today is to develop probability models using experimental and theoretical probability. Our success criteria: I can explain the meanings of experimental probability and theoretical probability. I can find experimental and theoretical probabilities, and I can use the probability to make predictions. All right, so the first thing here, we're going to look at experimental probability. So experimental probability is probability that is based on repeated trials of an experiment is called experimental probability. So you're taking the probability of the event, which is equal to the number of times the event occurs over the total number of trials. Okay, so here's an example. All right, so looking at example 1, it says finding an experimental probability. The table shows the results of spinning a penny 25 times. What is this experimental probability of spinning a head? Okay, so this is an experimental probability because we're doing an experiment. Okay, we're going to take the penny, spin it 25 times, record the results. Okay, so if you look at the results, okay, the number of times of spinning a head, right, that's what we're looking at, is 6. So we get 6 as our numerator. Okay, and our denominator is the total number of trials. Well, we spun the penny a total of 25 times, right? Which you can see, okay, if we did 6 plus 19, right, that would also give you that 25. Okay, so to figure out what this probability is or what this means a little bit more, it's helpful to change this to a percent. So we can change the denominator to 100. Okay, so that we have a better understanding of what this means. So I can do that by multiplying by 4, okay, which would give me 24 over 100, or 24% of the time. Okay, so that was an experimental probability. Okay, if you were talking about the word theoretical probability, okay, theoretically, we would expect it to be about 50% of the time. Okay, but the experiment showed it was only 24%. All right, so let's try another example below. Okay, this one says you're going to roll a number cube. A number cube, okay, is the same thing as a dice. Okay, so we're going to roll a dice 50 times. Find the experimental probability of the event. Okay, so first thing, right, I want to figure out the frequency or the number of trials. So I want to add up, okay, all of those frequencies. So I'm going to add 10 plus 4 plus 8 plus 11 plus 11 plus 6, okay, so that I can figure out how many times, okay, we rolled that dice, okay, and I can see here if I read, right, we rolled it 50 times, okay, so this should all add up to 50, okay, but if they didn't tell you that, you can add those up. All right, so if I want the probability of rolling a 3, okay, well, I rolled a 3 8 out of 50 times. Okay, again, I can simplify this, okay, because we always give our answers in simplest form. Okay, so if I simplified, I can divide by 2, which would give me 4 out of 25, okay, in simplest form, okay, or I can change it to a denominator of 100 by multiplying by 2 to get it as a percent, right? So if I wanted my answer as a percent, 8 over 50 times 2 would be 16 over 100, or 16% of the time. Okay. Question 2 says rolling an odd number. Okay, well, an odd number would be 1, 3, and 5. Okay, so if I added those up, let me switch back to blue. So if I did 10 plus 8 plus 11, right, all divided by 50. Okay, that would equal 18 plus 11 would give me 29 over 50. All right, again, I can, this is simplified already. Okay, so that would be my simplified answer. Okay, I can change it to a percent by multiplying by 2 to get that denominator to 100, which would give me 58%. Okay, so again, my experimental probability is that rolling an odd number would happen 58% of the time. Theoretically, it should happen 50% of the time, right? Half the time it should be odd, half the time it should be even. Okay, so that's the difference between experimental and theoretical probability. All right, so let's take a look further at theoretical probability. So theoretical probability, when all possible outcomes are equally likely, the theoretical probability of an event is the quotient of the number of favorable outcomes and the number of possible outcomes. Okay, so if we were looking at example 2, it says you randomly choose one of the letters shown. What is the theoretical probability of choosing a vowel? Okay, well, our vowels, right, are E, O, and E. Okay, so we have 3 different possibilities for vowels. So we have 3 favorable outcomes. Okay, there's a total of 1, 2, 3, 4, 5, 6, 7 letters. Okay, so our theoretical probability of choosing a vowel is 3/7. Okay, here, if you were trying to change this to a percent, this doesn't go nicely to a denominator of 10 or 100, so I can solve that by doing long division. 7 doesn't go into 3, so we get a 0. 7 goes into 34 times, you get 28. Subtract, you get 2. 7 goes into 20. 2 times, you get 14. Subtract, you get 6. 7 goes into 60 8 times. You get 7 times 8, we get 56. Subtract, you get 4. 7 goes into 45 times. Okay, that would be 35. Okay, etc. We could keep going. So we end up with this being about 43%. Okay, remember, you don't have to do long division. You are more than welcome to use your calculator to divide and figure out what that percentage is. Okay, same idea here for the try it. It says, what is the theoretical probability of randomly choosing an X? Well, here, right, there's only one X. So there's one favorable outcome out of 7. Okay, I'm just going to use my calculator here for this one. So if I divide 1 divided by 7, I end up with 0.14. So it's about 14.3%. All right, example 3. Okay, it says the bar graph shows the results of rolling a number cube 300 times. Remember, a number cube is just a 6-sided dice. Okay, how does the experimental probability of rolling an odd number compare with a theoretical probability? Okay, so let's start with theoretical. All right, so theoretically, okay, rolling an odd number, okay, there are 3 options. You can roll a 1, a 3, or a 5. So you have 3 options out of 6, right, because there's 6 sides, okay, which would simplify to 1/2, okay, or 50%. All right, if we were looking at the experimental, all right, we need to add up those pieces. So we have 48 plus 50 plus 49 over the 300 times. So if we add those up, we end up with 147 out of 300. So again, I'm going to use my calculator here to figure out what that is. So 147 divided by 300 gives me 49%. Okay, so it says, how does experimental probability of rolling an odd number compare with the theoretical probability? Okay, these are very close. Okay, they're very close because we did so many experiments, right? The more times that we're doing the experiment, okay, the closer those numbers should get in theory. All right, so let's try another one. So this says, how does experimental probability of rolling a number greater than 1 compare with the theoretical probability? Okay, so same idea. So if we looked at the theoretical probability, okay, so theoretically, if you're rolling greater than a 1, you can roll a 2, a 3, a 4, a 5, or a 6. So you have 5 different options, right, out of 6. Okay, so if we divide that, 5 divided by 6, we end up with 83.3%. All right, so then let's look at the experimental. All right, so if we look at the experimental, I need to go back up to my chart. Okay, so anything greater than a 1 would be any of these pieces here. So I need to do 53 plus 50 plus 52 plus 49 plus 48 all over 300. All right, so if we figure that out, and I added those up, that gives me 252 over 300. And if I divide that, that gives me 84%. Okay, so once again, okay, these are very close together, okay, because again, we had so many trials. We had 300 trials, so our experimental and our theoretical are very close. All right, example 4, okay, it says using an experimental probability. A bag contains 50 marbles, okay, so we know that there's a total of 50 marbles. Okay, you randomly draw a marble from a bag and record its color and then replace it. The table shows the results after 30 draws. Predict the number of red marbles in the bag. Okay, so we know that in the bag we had 9 out of, right, there were a total of 30 draws. Okay, I'm going to simplify this, okay, to make it a little easier to solve. So I'm going to divide by 3, and I get 3/10. Okay. However, our bag contains 50 marbles. So if we think 3/10 of the marbles are red, and we have a total of 50 marbles, okay, we are going to multiply those together, okay, to get our answer. Here I can simplify. 10 goes into 50. That becomes 1. That becomes a 5. 3 times 5, we end up with 15 red marbles. Okay. Same thing for the question below. All right, so let's try that one. So it says an inspector randomly selects 200 pairs of jeans and finds 5 defective pairs. About how many pairs of jeans do you expect to be defective in a shipment of 5,000? All right, so we have 5 out of 200. I'm going to simplify this by dividing by 5, which gives me 1/40. All right, so 1/40 of the jeans should be defective out of 5,000 jeans. All right, so I'm going to multiply those together, or do 5,000 divided by 40, and that gives me 125 jeans. Okay, will be defective. All right, last example here. Okay, it says the theoretical probability of winning a bobblehead when spinning a prize wheel is 1/6. The wheel has 18 sections. How many sections have a bobblehead as a prize? Okay, well, we know that 1/6, okay, of them have bobbleheads. right? So I want to know, well, out of 18, right, how many is that? Okay, so if we think about this one, easy way to do this, right, to get from 6 to 18, I multiply by 3. So if I do that to the numerator, okay, 3 of the sections. You have to have a bobblehead as a prize. Okay, and then the last one, it says the prize wheel is spun 540 times. About how many bobbleheads do you expect to be won? So again, remember, we're winning 1/6 of them. Okay, or 1/6 of the time we're winning. Okay, and we're spinning it 540 times. Okay, so if we solve that, so 540 divided by 6, we end up with 90 bobbleheads won. All right, guys, that is it for today's notes. If you are confused on anything or you would like to go back, rewatch it, you are more than welcome to replay it, go back, okay, make sure your notes are complete, okay, and then you guys can go on to your student journal and your skills trainer. All right, guys, that's it.